Good morning. This is your Stats Sensei, Mr. Spensei, and this is a warm-up for reviewing the empirical rule and the normal distribution. So, directions using the scenario and the graph below illustrate the empirical rule. You must show three standard deviations above the mean and three standard deviations below the mean. You must clearly label z-scores and actual values. Let's go ahead and start with the empirical rule before we go any farther. So the empirical rule and z-scores mean we're going to start at the mean for all z-scores is 0, and we have a 1, 2, and 3. This is for all z-scores, -1, -2, and -3. And don't forget, the normal curve goes to negative infinity theoretically and to positive infinity theoretically. Well, they also wanted us to illustrate the empirical rule, and the empirical rule basically said that plus or minus 1 is 68%. And we also know that plus or minus 2 is 95%. And then ultimately we get all the way up to plus or minus 3, which is at 99.7%. I'm going to go ahead and put plus signs just because we remember, but it's certainly not required. All right. Also, remember the normal curve is centered at 0. The mean, the median, and the mode are the same. And I'm going to go ahead and put a Z out here in blue because these are my Z-scores, just as a reminder that these are Z-scores. All right, so we've illustrated the empirical rule. We've shown the number of standard deviations. But what we have not shown is the actual value, so we need to read. Suppose the weekly commute time of the city residents are normally distributed with a mean of 50. So the actual values have a mean equal to 50. So I'm going to go and put a 50 here and change pins and go to 50 as my mean. And I'll put mean there. And while we're thinking about it, let's go ahead and talk about our z-scores. Z-scores, mean equals 0, standard deviation is 1. All right. But here we're working with actual values, and our actual values have, and I'll go ahead and write this down, our actual, they said has a mean equal to 50, and it has a standard deviation equal to 6. Cool. That means between each one of these, I'm going to be changing by 6, which means if I'm going up, this is going to be 56, this will be 62, and this will be 68. Also going down is changing by 6. So subtracting 6 from 50, we get to 44. Subtracting 6 from 44, we get to 38. And 38 minus 6 takes us to 32. So using the empirical rule to answer the question, 68% of residents commute between, well, 68% is plus or minus 1, so 44 and 56 minutes. 95%, well, that's plus or minus 2 standard deviations, so 38 to 62. And by the way, the empirical rule is an approximation, it's not exact. So 38 and 62. And then plus or minus 3 is our 99.7. So between 32 and 68. All right, that's using our empirical rule to do the approximation. The next thing we need to do is we need to use our actual values to figure out these. So it says calculate the probability, the following probabilities. Well, the probability that x is less than 40. Well, at that point, I should be drawing a graph. And my graph is going to be centered at a mean of 50. And I have an x, my lower value is 40. Well, not my lower value, but we want the probability that x is less than 40. And my lowest value is actually shading to negative infinity. All right, so we're going to go to what's on the calculator. Take a look. Second quit. We're going to go second vars, normal CDF. So that's where we're going for the normal. So we're going to write norm CDF because that's where we went to. Norm CDF. Our lower bound, well, we shaded to negative infinity, so we're going to put in a negative infinity sign. We shaded up to 40. We have a mean of 50 and the standard deviation. Our actual standard deviation was 6 because that's only what the calculator asked for, lower, upper, mean, standard deviation. So we're going to write that down, and then we're going to come back and put in our labels, which are basically LUMO, lower, upper, mean, and standard deviation. So let's go ahead and do that. Now, in this case, I already have a lower in there, but if I didn't, I would press the negative sign right down here, followed by a 9 raised to the 99th, because that is the smallest value the calculator will take. All right, that's the smallest value our calculator will take. So negative 9 raised to the 99th. Upper, well, we shaded up to 40. We said we had an actual value mean of 50 and a standard deviation of 6. Press paste, and we end up with 0.04779. So, and I'll box my answer, equals 0.0477. And we'll just truncate it and box it in like that. All right. So number 2, probability that X is greater than 54. All right. So when we're going to go ahead and draw our picture. All right. So there's my normal curve. Well, the actual mean was at 50. Well, we want to start at an X value of 54, and we're shading up to positive infinity. Well, I'm going to go to the same place I went to on the calculator before, which is norm CDF. So norm CDF. And my lower bound, well, my lowest part of my shading is 54. The highest part of my shading is positive infinity. We have a mean of 50, and they still have the actual standard deviation of 6. Let's LUMO that out. Lower, upper, mean, standard deviation. And second vars, normal, CDF, lower. Well, we said our lower was 54. Our upper is infinity, so 9 raised to the, and by the way, I used the little caret for my raise, 99th. Mean of 50, standard deviation of 6, that didn't change. And we end up getting 0.2524. Box that in. All right, this case, we want it between 53 and 61. Well, we still need to draw our picture every single time. You'll get so much smarter if you do. I didn't give myself much room here. This is 50. Well, 53 is up here, and so is 61. So I'm looking for the area between 53 and 61. We're going to go to exactly the same place in the calculator. Well, the lower part of my shading is 53. I stopped at 61, so that's my upper. My mean is still the actual mean of 50, and my standard deviation is 6. Label them lower, upper, mean, standard deviation. So second vars, normal, CDF, lower 53, upper 61, mean and standard deviation remaining the same. And we end up getting 0.2751. So this area right here, there's a 27% chance that it would be within this area. So 0.2751. Finally, we want it between 42 and 51. So we're going to draw a normal curve. I'm trying to give myself a little more room than I did last time. So I have a mean of 50. I have a lower bound of 42, which is down here below the mean at 42. That's my X. And my upper bound is 51. I should call this my lower and my upper. There's my upper. And I'm looking for this area in between. So once again, we're going to be in norm CDF. The lower part of my shading started at 42. Then I shaded all the way up to 51. I have a mean of 50 and a standard deviation of 6. LUMO, lower, upper, mean, standard deviation. Second vars, normal CDF, lower was 42, upper was 51. Everything else was the same. And we get 0.4749. So about 47% is 0.4749. All right, last question. From a random sample of 500 commuters, that's interesting. How many would you expect to have a drive time of more than 60 minutes? Wow. So this is a multi-step problem here. I need to calculate, first off, let's find out the probability that they'd have more than a 60-minute commute. Well, to do that, I'm going to draw my normal again. And remember, our mean is 50. That hasn't changed. We have a lower bound of 60 minutes, and we're going all the way up to upper. So let's calculate this out using normal CDF, just like we have been. So norm CDF, the lowest part of my shading was 60. The highest part was positive infinity. I have a mean of 50 and a standard deviation of 6. So labeling it lower, upper, mean, standard deviation. That's our LUMO. Let's calculate that probability out. So second vars, norm CDF, 60 is our lowest part of our shading, 9 raised to the 99th, and that remained the same. And we end up getting 0.04779. And we're just going to stop right there and truncate it, and I'll box that in. But that was the probability. And they want us to know how many from a random sample. So I need to set up a proportion here. So X is the number out of 500. We're looking for X, we don't know it. But it equals, this probability equals 0.0477. Now I can put this over 1 if I want to, and I will. And we're going to multiply the two numbers on the diagonal. And it ends up that we're going to divide by 1. So we're going to go equals 500 times 0.477 divided by 1. So 500 times 0.477 divided by 1. So about 238.5. So the expected, and this is our expected symbol, is 238.5. Now, if you'd use the actual percentage that the calculator gave you, and I multiply, oops, there we go. And I multiply that by times 500, it's going to change it slightly. Oh, and by the way, I have an issue. I made a mistake on my multiplication. Gotta check that. 500 times 0.0477 is about 23.85. So let me change that to 23.85. So almost 24. All right, I appreciate you watching and hope to see you on the next one. Thank you.